Welcome back everyone, Patrick here. Moving on to the next example, we're going to expand and simplify again these three expressions here, but in this case what we're going to do is we're going to plug in x equals 3, so a value of 3 for all these x values in the original expression and then in the expanded and simplified expression that we get, and they should have the same value. That's how we can verify or check our answer. So starting with part A here, notice we have negative 3 times 2x minus 3 times 5x plus 2. So what I'm going to do, I'm going to keep the negative 3 on the outside, and then I'm going to just multiply these two brackets first. So we'll have 2x times 5x, which gives us 10x squared, 2x times 2, which gives us positive 4x, negative 3 times 5x gives us minus 15x, and then we will have negative 3 times 2, which gives us minus 6, like that. And then again, from here to simplify, different ways you could do. You could distribute the negative 3. You could also simplify the bracket first. Notice that the 4x minus 15x, that simplifies to negative 11x. And then we have the minus 6. And then we could distribute in the bracket. So we'd have negative 30x squared plus 33x plus 18, like that. Right? And so from here, this is the simplified answer. You can't simplify that any further. There are no like terms. And now what we could do is we could check our answer. So what we're going to do is we're going to plug in an x value of 3 into this and into that. And hopefully they both give us the same value. So let's start off with the first expression, the original one. So we end up with that right there, right? We're plugging in 3 for x, and then we'll have 5 times 3 plus 2, like that. So over here we'll have negative 3. 2 times 3 is 6, minus 3 would give us 3. And then we'll have 5 times 3, which is 15, plus 2 would give us 17. And so we'd end up with negative 9 times 17. And then this here would give us what? Negative 153, like that. Negative 9 times 17. So negative 153 is what we get when we plug it into the original. Let's see what we get if we plug in 3 into this expanded version that we got. So we got 3 to the power 2 plus 33 times 3 plus 18, like that. So over here, we have to do the exponent first. So that would be 9. 3 to the power 2 is 9. And then we'll have 33 times 3, which gives us 99. Plus 18, and then we'll have negative 270 plus 99 plus 18, that would give us what, 117, like that, and then negative 270 plus 117 gives us negative 153 as well. Right, so just with that check right there, you can use any x values you want. In this case, we're using an x value 3. You could also use multiple x values. But just from that check right there, we could be pretty confident that this here is the correct expanded expression. So moving on to part B, same thing here. This one, I think the expansion is going to be a little bit more intense, but it's still going to be okay. So notice here we got x minus 7 times x plus 1 minus 2x minus 1 to the power 2. Now this 2x minus 1 to the power 2, we could also rewrite as 2x minus 1 times 2x minus 1, like that. So notice we have multiplication here, and then we have a subtraction in the middle. So we'll have x times x, which is x squared, x times 1, which is x, negative 7 times x is minus 7x, negative 7 times 1 gives us minus 7, like that. And then we'll have minus a multiplication of these. So when we multiply these, let's put it in a square bracket because we're going to have to take that negative and distribute it into the bracket. So we'll have 2x times 2x, which gives us 4x squared. 2x times -1 is minus 2x. -1 times 2x gives us minus 2x, and then -1 times -1 gives us +1, like that. And then from here, what we could do, notice we could simplify here. That gives us minus 6x, right? 1x minus 7x gives us -6x. And then from here, let's simplify the bracket first before we distribute that negative inside the bracket. So now we would just multiply everything by -1 inside the bracket. So we'll have x squared minus 6x minus 7 minus 4x squared plus 4x minus 1, like that. Yes, looks all good to me. And then from here, simplify like terms. X squared minus 4x squared gives us -3x squared. Then we'll have -6x plus 4x gives us minus 2x. And then -7 minus 1 gives us minus 8, like that. Right, so this here simplifies to that. So let's write this expression over here. And then let's check our answer. So let's first plug in 3 into the original. So starting with these two sets of brackets, we'll have 3 minus 7 times 3 plus 1, right? Plugging in for this x and this x, minus, in brackets, 2 times 3 minus 1, and then we'll have 2 times 3. That's actually to the power of 2. So let's just actually put an exponent here. So here we'll have -4 times 4 minus 2 times 3 is 6, minus 1 gives us 5. That's going to be to the power of 2, so we'll have -16 minus 25, right? We have to do the exponent first there. -16 minus 25 gives us -41. Right, so we got -41 by plugging in 3 over here. Let's see what happens when we plug in 3 into the expanded one. So we'll have -3 to the power of 2 minus 2 times 3 minus 8. Over here, we got to do the exponent first. 3 to the power of 2 is 9. -2 times 3 gives us -6 minus 8. -27 minus 14. -6 minus 8 is -14. -27 minus 14 gives us -41 as well. Right, so we got the same value for both. We could be pretty confident that that's correct. And then finally, part C, we got 4x times x minus 4 minus 2 in brackets 5 minus bracket x plus 4 over here. So this one's a little bit different. You got to be careful with these brackets here, but overall it's not too bad. So let's first start off by expanding over here. So we'll have 4x squared minus 16x. And then if you get something like this where you got like brackets within brackets, you want to deal with the innermost brackets first. So this minus 2, let's keep on the outside. Notice this x plus 4, we can't simplify any further. So what we can do is take this negative and distribute it into that bracket right there. So we'd end up with 5 minus x minus 4, like that. So we got rid of that innermost bracket. Now what you can do, you could actually take the -2, distribute it to all 3 here, but notice we could simplify this because we got this 5 minus 4. So we'd have 4x squared minus 16x minus 2. The 5 minus 4, that simplifies to 1, and then we got a minus x like that. So from here, 4x squared minus 16x, distribute -2 plus 2x, like that. So from here, 4x squared, -16x plus 2x gives us 4x squared. So -16x plus 2x gives us minus 14x. And then we got a -2, like that. So let's actually write this over here on the side. And let's see if this is correct. So let's plug in an x value of 3 for both of these expressions. So over here we'll have 4 times 3, then we'll have 3 minus 4 in brackets, minus 2, 5 minus 3 plus 4, like that. Right? Just be careful with all your brackets, just rewrite everything in the exact format that it's given. So from here, 4 times 3, that gives us 12. 3 minus 4 gives us negative 1, minus 2. And then over here, we deal with this bracket first. So we'd have 5 minus 3 plus 4 gives us 7. 12 times negative 1 gives us negative 12. Minus 2, we deal with the bracket first, times negative 2. Negative 12. Negative 2 times negative 2 gives us positive 4. Negative 12 plus 4 gives us negative 8. So that's what we get when we plug in 3 into the original expression. Now let's see what we get when we plug it into our simplified expanded expression. So we'll have 4, 3 to the power 2 minus 14 times 3 minus 2. Do the exponent first. This here would be 42 minus 2. This gives us 36 minus 44. Right? Negative 42 minus 2 gives us negative 44, and then 36 minus 44 gives us negative 8. Same thing that we got right there. All right, so just plugging in one x value doesn't guarantee, even if you get the same thing, that this is correct, right? There are situations where you just luck out and plug in an x value where both of them are the same, but it's a very rare situation. So if you do get the same values here by plugging in an x value, you could be fairly confident that your answer is correct. And this is a nice way to check your answer on a test. If you have the extra time, let's say you're expanding something, you get a certain value. If you have the time, if you want to check your answer, plug in a certain x value for both expressions and make sure you get the same value.